In this week's video, we will be discussing building ionic compounds. We will be doing two problems. The first problem says combine the following ions to form as many ionic compounds as possible. As you can see, I have 3 cations and 3 anions. The cations are barium, potassium, and sodium. And then my anions are carbonate, iodide, and my HPO4 2-. So the first thing I want to do is match my barium and my carbonate. Notice that they have opposite but equal charges. This will allow us to have our barium and 1 carbonate to form barium carbonate. You do not need to put any parentheses or ones when forming those species. Now I want to mix my barium and my iodide. Notice that the barium has a +2 charge and the iodide a 1-. That means I will need 2 iodines. So the answer would be BaI2. Now we can go to our third barium species. Notice that they have equal but opposite charges. So our answer in this case is going to be Ba. Then I'm going to have my HPO4 and those are all my barium species. Now I can go to my potassium. Potassium with carbonate, notice that my potassium is only 1+, so I will need 2 of them. So I can say K2, so that way I have a 2+ charge, and then I will have my carbonate, CO3, with the -2 charge, the charges then canceling each other out. For my potassium and iodide, we are going to have 1 each, so that will just be Ki. Finally, my last potassium species will be potassium with my HPO4 2-. So once again, I will need 2 potassiums and only 1 HPO4 to balance the charge. My last combination is with sodium. Sodium acts very similar to potassium, so now we are going to have our sodium mixed with our carbonate, so that is Na. We need 2 of them to match with the -2 charge of the carbonate, so that will give us Na2CO3. Finally, we will mix our sodium and iodide, so we will get Na with I. And finally, my last match will be my sodium with my HPO4 2-. So once again, I will need Na2 to have a +2 charge to match with the HPO4 2- charge to cancel out. These are the 9 combinations that we could build with our first problem. Biggest thing we can do is match and balance our opposite charges. The second problem for today says combine the following cations with the anions to make ionic compounds. The difficulty in this problem is identifying the various cations and anions. The best way of handling this problem is writing those individual ions out and then doing what we did on the last problem. Ammonium is one of our polyatomic cations. It is NH4+. Calcium is one of our elemental ions, and seeing that it's in column 2, it is going to be Ca2+. Finally, we have the transition metal of iron 3. The 3 in the Roman numeral tells you the charge that we are supposed to have on the cation. So this will be Fe3+. Finally, we have 3 anions. Nitrate is a polyatomic anion. That is NO3 1-. For perchlorate is part of the chlorate-chlorite family, and that is ClO4 1-. This is what we call an oxyanion. Finally, we have sulfite, which is SO3 2-. This differs from sulfate, which is SO4 2-. We have lost one of the oxygens. So now we can do the exact same thing that we did in the last problem. So the first thing we want to do is take ammonia and mix it with our 3 anions. So in this case, we have NH4, it's 1 plus. We can match it with nitrate, which is 1 minus. So we only need one of each species. That gives us NH4NO3. For our ammonia and perchlorate, we still have the opposite charges. So our salt is going to be NH4ClO4, and this is ammonium perchlorate. Our final species is ammonium with sulfite, but notice that the ammonia has a +1 charge, so we need 2 of them. When you have a polyatomic and you need multiples, you must put them in parentheses. So in order to get the +2 charge, we will put NH4 parentheses 2, and then we will write SO3 for our anion. You only use parentheses when dealing with the polyatomics. So now we will go to the calciums. So for calcium, we're going to mix it with nitrate, but we need 2 nitrates to balance the charge on the calcium. So we are going to have Ca parentheses NO3, the nitrate polyatomic, and we need a 2 to show that we have 2 of those species to balance the positive charge. For our calcium perchlorate, we're going to do the same thing. So we have Ca parentheses ClO4, and we put a 2 to let us know that we need 2 of them. Finally, our last combination for calcium is Ca and our SO3. Because they have equal and opposite charges, we only need to have 1 each. Notice there are no parentheses. Our last group is going to be the iron 3 group. So now we are going to take our +3 charge and our -1 charge of nitrate. So this will give us Fe, but we need 3 of our nitrates to balance the charge on the iron. So that will be NO3 with a 3. For our second combination, we have iron with our perchlorate. So we are now going to have Fe, still has a 3+ charge, so we need 3-, so that is ClO4, and we need a 3 as well to balance this charge. Finally, our last example is iron 3 with sulfite. Notice the +3 charge and the -2 don't match up easily. However, go to your least common multiple. So for our iron, we can do Fe2, giving us a +6 charge. This allows us to have SO3, and because it's 2-, we need to have 3 to have a -6 charge. This is what we commonly call the rule of least common multiple. In these examples, you have seen problems on trying to build ionic compounds from not only your elements, but your polyatomics. Good luck.